Pluto, a distant, enigmatic, and less prominent body, was once recognized as the ninth planet in our solar system, though later reclassified as a dwarf planet. It continues to captivate scientists and space enthusiasts alike. Recently, Pluto has resurfaced in public discourse due to provocative insights from leading astrophysicists such as Neil deGrasse Tyson and Miyoku. These experts have suggested that Pluto may be on a potential collision course with Neptune, an alarming notion that raises significant questions. Could such an extraordinary event truly unfold? And if so, what will be the consequences? This intriguing possibility has ignited debate over whether we are witnessing a rare, unpredictable cosmic phenomenon, or whether deeper, well-understood forces are at work beneath the surface of this potential celestial crisis. Pluto's status as a dwarf planet hasn't diminished the scientific interest in its behavior. In fact, recent discussions surrounding its orbit have highlighted just how peculiar it really is. Experts warn that Pluto's highly elliptical and tilted path brings it unusually close to Neptune's orbit, so close that some fear the risk of a catastrophic encounter. Could Earth face repercussions from such an event? To understand this better, we must examine Pluto's orbit. Unlike any of the 8 major planets, Pluto takes a staggering 248 Earth years to complete just one revolution around the Sun. Since its discovery in 1930, it has yet to finish a full orbit. Its path is not only stretched into an elongated oval, but is also tilted at an angle of 17 degrees compared to the relatively flat plane of the solar system. This gives Pluto a much more erratic trajectory compared to the other planets. One of the most fascinating and seemingly dangerous aspect of Pluto's orbit is its interaction with Neptune's. For about 20 years during each cycle, Pluto actually travels closer to the Sun than Neptune does, defying what many assume about their spatial order. Naturally, this prompts a question: why haven't Pluto and Neptune collided? The answer lies in the elegant complexities of celestial mechanics. After Pluto's discovery, astronomers sought to make sense of its strange orbital path. Unlike the other planets that mostly follow flat, circular orbits, Pluto's unusual inclination and eccentricity presented a challenge, especially since its orbit crosses that of Neptune. And yet, despite this intersection, Pluto's orbit remains stable. This is due to several interacting gravitational phenomena, particularly what's known as the three-body problem. The gravitational relationship between Pluto, Neptune, and the Sun, predicting the exact positions of these bodies over time, requires accounting for how each influences the others. One of the key stabilizing factors is a phenomenon called non-concurrent libration. In simple terms, it ensures that when Pluto is at the point where its path overlaps Neptune's orbit, the two bodies are always positioned at least 90 degrees apart. This consistent separation prevents them from occupying the same space at the same time, effectively avoiding a collision. Another crucial safeguard is orbital precession, a slow wobble in a planet's orbital orientation over time. In Pluto's case, this means that even when it appears to come close to Neptune's path, it is actually passing well above or below the giant planet, thanks to an inclined orbit. A further contributor to Pluto's stability is something referred to as VSK wobbling, named after 3 researchers, Zell, Kai, and their colleague, who studied the gravitational tug-of-war between celestial bodies. This wobbling effect helps explain how Pluto's orbit can remain consistent over long periods despite its chaotic appearance. It reveals an underlying pattern that balances gravitational influences from Neptune and the Sun, helping maintain order in what seems like orbital chaos. Altogether, these forces illustrate how even the most seemingly unstable systems in space can be governed by precise and intricate laws of motion. The three-body problem remains key to understanding not only Pluto's peculiar dance around the Sun, but also its long-term relationship with Neptune and other distant objects in the solar system. Even with the stabilizing influences at play, numerical simulations conducted in the late 1980s revealed that Pluto's orbit, while mostly secure, isn't immune to perturbations. Tiny changes in initial conditions could lead to significant long-term variations, keeping this distant world a subject of scientific fascination and ongoing study. Pluto's orbit is actually quite erratic. Small changes in its initial conditions can lead to dramatically different trajectories over centuries. Despite this apparent chaos, Simulations show that Pluto's orbit remains remarkably stable over immense timescales, stretching millions or even billions of years. To truly understand the dynamics between Pluto and Neptune, we must consider the gravitational influence of the outer giant planets, Neptune, Jupiter, and Saturn. Neptune plays a particularly crucial role. Pluto is locked in a special orbital resonance with Neptune. For every 2 orbits Pluto completes around the Sun, Neptune completes 3. This 3:2 resonance acts like a cosmic safeguard, helping keep Pluto on a stable path. However, Neptune isn't the only stabilizing force. Jupiter's immense gravity significantly contributes to maintaining the balance of Pluto's orbit, and Saturn also plays a part in this complex gravitational dance. Together, these planetary giants work to prevent Pluto from veering off course or drifting into Neptune's path. Without these interactions, our solar system would be far more chaotic, with planets potentially colliding or being ejected from their orbits, causing widespread instability. The mere suggestion of a potential Pluto-Neptune collision underscores the complexity of celestial mechanics. It also highlights the importance of studying orbital stability in greater depth. Understanding these gravitational interplays helps us comprehend not just Pluto's behavior, but the fundamental structure and functioning of our solar system. Though Pluto's orbit might seem chaotic at first glance, it exemplifies the intricate balance of cosmic forces at work. This irregularity is a key example of what's known as orbital chaos, a condition where even the slightest variation in position or velocity can drastically alter a body's future path. Computer simulations have been instrumental in exploring such behaviors, allowing scientists to model how Pluto and Neptune influence one another through their gravitational pull. These simulations reveal that while mechanisms like orbital resonance and precession help stabilize Pluto, the orbit still exhibits sensitivity to its starting conditions. This makes long-term predictions exceedingly difficult. Even tiny discrepancies in data can lead to vastly different projections of Pluto's future movement. Despite these uncertainties, Pluto has maintained a stable path for billions of years, suggesting that even within apparent chaos, an underlying order persists. Predicting the motions of celestial bodies, especially those with complex, irregular orbits like Pluto's, remains one of astronomy's greatest challenges. Numerical models provide valuable insights, but their reliability hinges on pinpoint accuracy in initial data. Beyond its technical implications, Pluto's story serves as a compelling reminder of the ever-evolving and dynamic nature of our universe. Even with modern advancements, Pluto demonstrates how much we still have to uncover about space. The gravitational influences of the giant planets on Pluto's trajectory reveal broader truths about solar system dynamics. Each planet's position has the potential to affect the stability of others. So, why are some leading astrophysicists sounding alarms about a possible collision between Pluto and Neptune, despite the apparent safeguards in place? Neil deGrasse Tyson, a prominent astrophysicist and a key voice behind Pluto's reclassification from a planet to a dwarf planet, offers an insightful take. He views these orbital mysteries not as threats, but as opportunities to better understand our solar system's evolving nature and the fascinating complexities that govern planetary motion. In examining Pluto's role within our ever-evolving solar system, Neil deGrasse Tyson doesn't view its reclassification as a loss, but rather as a necessary update that reflects our growing understanding of celestial bodies. His perspective on celestial mechanics embraces constant exploration and refinement. He sees Pluto's complex orbit as a reminder of just how much remains to be discovered about the cosmos. Although Tyson remains optimistic about space research, his openness to the idea of a potential Pluto-Neptune collision highlights the many unanswered questions in planetary science. Could such a collision actually occur, or is it simply a misunderstanding of the current orbital dynamics? For now, this uncertainty only deepens our curiosity and underscores how much we still don't know about our own solar system. The idea of a Pluto-Neptune collision opens a door to fascinating questions about the forces that govern planetary motion. Given their vastly different compositions, Pluto being a frozen dwarf planet and Neptune a massive gas giant, a collision between the two will be monumental, likely observable from immense distances. Pluto's surface is covered in nitrogen ice, and its thin atmosphere contains nitrogen, methane, and carbon monoxide. Neptune, on the other hand, is composed mostly of hydrogen, helium, and other light elements, surrounded by a dense, stormy atmosphere. Any interaction between these two would have significant consequences. However, Neptune's gravity alone doesn't keep Pluto in check. Jupiter, the solar system's largest planet, exerts a powerful gravitational influence that also contributes to Pluto's orbital stability. Saturn plays a role as well, creating a complex gravitational environment in the outer solar system. These combined forces make a catastrophic encounter between Pluto and Neptune highly unlikely. Adding another layer of protection is the orbital resonance between the two planets. Pluto completes 2 orbits for every 3 of Neptune's. This gravitational dance ensures that, although their orbits cross, they never actually collide. It's a brilliant example of how harmony can emerge from apparent chaos in space. Still, this balance is delicate. Small changes in orbital speed or position, perhaps triggered by a passing star, an undiscovered celestial body, or even internal factors like tidal forces, could disrupt this resonance. This possibility fuels the need for continuous observation and analysis. As technology advances, scientists are refining their models and uncovering new details about the intricate gravitational interplay in the outer solar system. These efforts may reveal whether Pluto and Neptune will remain on their current paths, or if unseen forces could shift the balance. One such force might be the elusive Planet 9, a hypothetical body theorized to exist on the fringes of our solar system. Some scientists believe its gravitational pull could be affecting the orbits of distant objects like Pluto, subtly pushing them toward destabilizing trajectories. While Planet 9 has yet to be confirmed, its potential existence adds another layer of mystery and complexity to the study of outer planetary motion. Moreover, the solar system itself is not a fixed structure. The Sun, the central gravitational anchor, is slowly losing mass due to solar wind. As it does, the orbits of all planets, including Pluto and Neptune, will gradually expand. This subtle shift could alter their long-term orbital relationships. Additionally, passing comets and small celestial bodies, although rare in their influence, can also disturb planetary paths in unpredictable ways. Taken together, these forces paint a picture of a solar system in flux, dynamic, interwoven, and full of hidden mechanisms. Pluto's orbit may appear stable, but it is subject to an ongoing gravitational choreography that reflects both the known and the unknown. Continued exploration will not only help us understand the potential for a Pluto-Neptune collision, but also bring us closer to unraveling the broader mysteries of planetary motion and cosmic evolution.